Algae are basically everywhere in the ocean. Most of the time you don't see them. Algae feed food webs, and all the fish we eat basically are derived from algal material. The key thing that leads to algal blooms is when the rate of growth exceeds the rate at which they are either eaten or washed out of the system. And so there's a few key factors that can control that. The first is how fast they grow. So nutrients can make them grow faster. Temperature can make them grow faster. And it's very hard to say what the optimum temperature is, because some algae love warm conditions and some algae like cooler conditions. The factor that's probably contributed to the South Australian algal bloom mostly is really warm conditions. So the ocean over this summer and autumn period has been about 2.5 degrees above the long-term average, which has probably made this particular species of algae, Karenia mikimotoi, grow faster than they normally would. The other thing accompanying those high temperatures is the fact that the ocean's been relatively calm. So that means that there's very little exchange of water and mixing of the water, which has allowed the algae to accumulate. And so that was the other factor I mentioned, is how fast they're washed out or moved out of the system. And so I think they're the two key factors, and I think the experts generally agree that that's the case. Even with optimum temperatures, however, the algae do need a source of nutrition. So the question is whether this has been affected by recent events. So 2 years ago, there was the Murray floods, which did introduce a lot of water into the region where the bloom now is. 2 years is a reasonable time for those nutrients to hang around. So there's some question about whether that affected the bloom or not. The other source of nutrients in that area is periodic upwelling. So the upwelling is where deeper water from the ocean mixes with the surface water, bringing with it nutrients. That hasn't occurred for, I think, around a year or so. So the direct influence of upwelling is probably questionable as well. However, those two events, so upwelling and the Murray, does introduce nutrients into the system, which is taken up by the food web. Those nutrients are then recycled back into the water, back through algae, back through the water, and so on and so forth. And so the question is, how long has that recycled nutrients been hanging around in the system? And again, low rates of flushing because of the recent calm events may have contributed to more retention of nutrients in the system, which possibly contributed to the bloom, but I think that that's probably of secondary importance. Thousands of species of algae, and so each different species of algae has a strategy to survive as best as it can. Some of those species have a strategy to produce toxins, and sometimes when the conditions are just right or just wrong, depending on your perspective, those toxic species get an edge and then they take off. The exact reasons for that, I think, is a bit of a mystery. It's often a unique set of environmental conditions that sets those particular species off. And it often is actually just warm and still conditions. Not always, but mostly. The type of nitrogen or the type of nutrients that this species of algae, Karenia mikimotoi, likes is the sort that comes out of decaying fish and organic matter. So you could potentially argue that by killing fish, they're actually feeding themselves. And it's not too far from the truth, because these organisms are what's called mixotrophic. So mixotrophy is where they can actually eat organic matter in the same way as us, but they can also photosynthesize and produce the food they need just from sunlight. So around Australia, algal blooms typically occur under very warm conditions and also under very still conditions. So these are the types of conditions that we expect to see more of under climate change. The other one is nutrients. So in some systems, such as the Gippsland Lakes, nutrient inputs we know play a very strong role in those types of algal blooms. So we need to manage nutrient runoff from the catchment as much as possible, improve farming techniques, better urban infrastructure to reduce nutrient runoff. The other factor that can also drive algal blooms is bushfires. Rain events following fires lead to runoff of that ash into estuaries and coastal regions, which actually then drive further algal blooms. And so the 2020 fires, there was also a fire in 2007, which were known to have driven multiple algal blooms around the country. So again, more fires driven by climate change can also enhance algal blooms. So what can we do about algal blooms? Probably the main one is do our best to mitigate climate change. The warming world is going to lead to more algal blooms. I think that's fairly clear, and it's quite unpredictable about what form they take and where they occur. The other one is reducing nutrient runoff from catchments.